All right, Algebra 1A students. Welcome to part 1 of lesson 1-9. Today we're going to start talking about equations, meaning things with equal signs that have two variables in them, x and y as well, or a and b, or two different letters, two different variables in the same equation. And we're going to start talking about what the solutions of those equations look like. So the solution to an equation with two variables is an ordered pair, xy, that makes that equation be true. Okay, so xy comes from our coordinate grid, as we know. So the ordered pair xy, some number for x and some number for y that make the equation true, is called a solution to that equation. Okay? So part of what your practice problems will look like tomorrow is this. They'll ask you, is this certain point a solution for this certain equation? So they give you an x value and they give you a y value in that ordered pair. X is 3, y is 10. Is that a solution of the equation y equals 4x? That's what they want to know. They want you to test it. They want you to see and tell them yes or no. So all we have to do to check this is instead of x here, I'm going to put 3 because I know 3 is supposed to be my x number, and instead of a y, I'm going to put a 10. Okay, so I end up with this equation here, which says 10 equals maybe 4 times 3. So we substitute 3 for the x, 10 for the y, and it says 10 equals 4 times 3, right? Well, we should know 4 times 3 is 12, so what we end up with is 10 and 12. Are 10 and 12 equal? No, they're not equal. So 310 is not a solution because 10 and 12 are not equal to each other. So 310, this point that they tried to give me is not a solution. So we would say a big fat no on that one. Okay. So now I have another equation here for you. This equation is y equals 4 times x. Y equals 4 times x, which is the same equation we had up here. Actually. Y equals 4 times x. But I've got a bunch of new points for you to try. X values and y values. Remember, x value comes first, so put x, this number in for x, in for x, in for x, in for x, and see which ones actually work and which ones really don't work. So give me a yes or a no. Are these 4 points solutions to the equation y equals x, or y equals 4x, excuse me. Once you have 4 answers down there, 4 yeses or nos, come on back, I'll show you what we should get. Alright, the first one here is most definitely yes, because if I put 5 in for x, I get 4 times 5, which is 20, and my y value is 20, so yes, that one works. The same thing is true for the next one when it's a negative. 4 times a negative 5. Positive times negative would be a good guy leaving town. That's bad. So the answer should be negative, still 20. So yes, this is the correct y value here. The next one is absolutely a no. They have the points, the x and y values flipped around there. If I put negative 20 in for x, 4 times negative 20 is actually negative 80. So negative 5 does not equal negative 80. And then the last one here is also a yes. 4 times 1.5 is actually 6. Okay? So hopefully we understand how we plug in and check to see if a specific ordered pair is a solution to a certain equation. Okay? Now the other thing that is going to be in your practice problems is about tables, like tables of values. Okay? Tables of values is what we're talking about here. And we're going to start looking at a lot of different ways to represent different mathematical situations. Okay, so for example, we have here Carrie and her sister Kim, both born on October 25th, but in different years. Kim was born 2 years before Carrie, so Kim is 2 years older than Carrie, 2 years before her. They're asking us how we can represent the relationship between Carrie's age and Kim's age in different ways. Okay, so we're actually going to take a look at a table that they give us, which we could come up with ourselves, certainly, and we're going to try to write an equation with two variables in it from this table. Okay, So the first thing that they do is they make a table with Carrie's ages and Kim's ages in different years. So what they're saying here is when Carrie was 1 year old, Kim was 3. When Carrie was 2 years old, Kim was 4. 3, 5, 4, 6, 5, 7, and so on. When Carrie is 10, Kim is 12. When Carrie is 100, Kim will be 102. Okay, so they're just making a table out of this pattern. And what they want us to do is write an equation now from this table. So remember that today we're talking about equations with two variables. So here we should have two variables. And it's okay if you want to use x and y, but I'm going to use C for Carrie and K for Kim. Okay? C for Carrie, K for Kim. Okay, I don't like the idea of letting X be Carrie's age and Y be Kim's age. I'm just going to use C and K for Carrie and for Kim. Okay? So the equation we could write, well, what do we know about Kim's age? Kim's age is equal to something about Carrie's age, right? If I know Carrie's age, what do I have to do to Carrie's age to get Kim's? Well, I have to add 2 years, right? I have to add 2 years. So Kim's age is really Carrie's age plus 2. So I now have this nice equation. Kim's age is Carrie's age plus 2. K equals C plus 2, where K is Kim's age, C is Carrie's age. If I take Carrie's age and add 2, I get Kim's age. Okay? And then we can obviously ask ourselves questions about that equation. Like the question, when Carrie is 26, how old will Kim be? Well, we just have to take the 26 and say that's how old Carrie is. Plug that in here. 26 plus 2 would make Kim be 28. Right? We could also ask similar questions about Kim. We could say if Kim is 40, how old is Carrie? Well, 40 equals Carrie plus 2. So now this is an equation that we would find the solution for. Now there's just one variable, like we did last week. So what number would we have to add to 2 to get 40? Well, we'd have to add 38 plus 2. So Carrie would be 38 in that situation. Okay, so we can look at a table, hopefully, and write equations from that table, or create a table and then create an equation for it. Okay. So we have equations with two different variables, and we're able to plug numbers in there to potentially find solutions by plugging a number in for one variable, finding the other one. Or we can plug an x and y value in and solve, or check and see if the coordinate point they give us is a solution. If you have questions about either of those things, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.